Today we're going to show you 3 different ways that we solder electronic components to printed circuit boards. We'll talk about 3 different forms of solder and 3 forms of flux, a material that removes any oxidation and prepares the metal areas to be bonded. So the first technique is called reflow. This is used for surface mount technology, or SMT, components. For this we use solder paste, a paste of flux with tiny balls of solder suspended in it. The paste is applied to the board with a stencil, and the components are stuck into the paste using a robotic pick-and-place system. Then the board goes into the reflow oven. This is a convection oven with multiple different temperature zones inside. In the oven, the board is slowly heated and the flux goes to work until the solder beads melt and flow into place, then cool and solidify. To do a double-sided SMT board, you do one side and then flip it over and repeat the process. On the second pass, we don't let the bottom side get quite as hot, but the solder will flow again, so experienced board designers know to put all the heavier components on the top side as a matter of design for manufacturing. The second technique is wave solder, where we have a wave of molten solder for the boards to pass through. This is used for through-hole and mixed technology boards. As boards go in, the underside is sprayed with flux. And as the board travels through the machine, it is slowly heated and the flux mostly evaporates before the board passes through the molten solder wave, actually several different kinds of controlled waves, to completely fill in all areas of the board. For double-sided boards to be wave soldered, you place the SMT components first on one side, using glue to hold them in place, and then place the through-hole components on the other side. The SMT components go through on the underside and get soldered in the wave, along with the through-hole pins. For both reflow and wave solder, we use a thermal profiler to program the different temperature zones. We need to ensure that all areas of the board reach the proper temperature for the right amount of time for optimal soldering without overheating. At Z-axis, we create and store a unique profile for each board design we run, showing temperature versus time for multiple areas on the board as it travels through the oven or wave solder. Finally, some components are best hand soldered. The flux is usually in the core of the solder wire. We hand solder components like lithium batteries that can't go in the ovens, or tall, tippy parts. We may also hand solder parts like this, using a fixture to hold a tight tolerance on mounting angle. Everyone involved in soldering should be trained to IPC standards. There is an initial 40-hour classroom training course with recertification every 2 years. It includes an online exam through IPC and a hands-on exam in which participants assemble a test board and have their work assessed by a certified trainer. At Z-axis, we have a certified trainer on staff for both IPC 610 and IPC J standard training. There's a lot more to soldering than we can show in a short video. For example, leaded versus lead-free solder, water-soluble versus no-clean flux, how to do thermal profiling, and many other considerations. See our related videos or contact us to learn more.
This video shows basic soldering technique and the equipment used to solder. There are two main types of soldering iron. The iron to the right has a station which shows the temperature on the display. The controls adjust the desired target temperature. The one on the left works at a fixed temperature but is used in the same way. If you're using a digital iron, then set the target temperature to around 350 degrees C and wait for the iron to heat up. When you're not soldering, remember to keep the iron in the holder. Be careful when you're soldering not to put the iron in contact with the lead. Some soldering irons have PVC coated leads which will melt through easily and pose a risk of electric shock if touched. The best leads to use are made from silicon, which won't melt at the temperatures soldering irons reach. The other item you'll need is of course solder. Solder is a low melting point alloy which flows easily when heated to its liquid state. When it cools and solidifies, it fuses to the surface of a metal at the molecular level, providing good electrical conductivity between two metal surfaces. Solder normally contains flux, which helps the solder to flow, and also helps make a good contact by removing the oxides on the surface of the metals being joined. Although modern flux is not toxic, when soldering you should always use a fume extractor to prevent the fumes from the flux irritating your lungs. The fumes are extracted by a high-efficiency particulate air filter, or HEPA filter, before the air is returned to the room. Before you handle the components, it's strongly advised that you wear an earthing band to prevent electrostatic damage to the components. There are two different soldering types, surface mount and through-hole. Surface mount connections are made by heating components with pre-applied solder in an oven so that it melts and joins to the surface of the board. For this tutorial, we'll look at plated through-hole soldering, which is done on boards with printed circuits on both sides. Through-hole soldering is when components are pushed through a hole in the board and soldered from the other side. The solder flows through the hole to make the best possible contact. First, take your component and create a bend in the legs with a pair of pliers, so that each leg is at a right angle. Push the legs through the holes in the board at the appropriate place and push it all the way down. Then turn the board over and bend the legs slightly to lock the component in place. When the iron is up to temperature, first clean the tip of the iron on the wet sponge on the iron holder to remove any excess solder and flux residue that might be there. You then apply heat directly to the pad for about a second, before placing the solder in contact with the pad. When the solder starts to melt, feed it in for about a second. Take the solder away, but leave the iron on the pad for another second. Then take the iron away and let the connection cool. Let's have another look at that. Before you make another connection, it's important to remove any excess solder remaining on the tip of the iron. This is because any flux in the solder will vaporize until there's none remaining. If you try to make a connection with solder without any flux in it, you risk making a bad connection. When you turn the board over, you should see that the solder has flowed through the hole by capillary action, guaranteeing a good contact. Trim the leads just above the solder using some wire cutters. When you cut the wires, be careful that the cut end is held captive so that it doesn't fly off. This can be done by putting your finger on the end when cutting. If you make a bad joint or want to remove a component, you can remove the solder by using a desoldering pump. This is a spring-loaded piston with a trigger which when released creates a vacuum which sucks the solder up. Cock the pump. Use the iron to melt the connection and put the tip of the pump onto the melted solder, then release the trigger. You might have to repeat the operation several times to clear all of the solder. An ideal solder should look like a cone with slightly concave sides, showing that the solder has flowed through the hole. You can see all the solders here look regular. Bad joints are noticeably different to the concave cones of good joints. If your joint looks like any of these, then it'd be wise to remake it. Bad joints can lead to intermittent connections or no connection at all.